Hello students, and welcome to section 7-3, Similar Triangles. So today we're going to identify similar triangles, and here are three ways to show that the two triangles are similar. The first, as you can see, it's defined as angle-angle similarity. Two angles of one triangle are congruent to two angles of another triangle. So if all you have are two angles that correspond to another triangle's two angles that in fact are also congruent, then those are considered similar triangles, again by angle-angle similarity. Side-side-side similarity is when the measures of the corresponding side lengths of the two triangles we're looking at are in proportion or are proportional. So side, side, side. Notice it doesn't refer to anything being congruent. It is, again, sides being in proportion. Side, side, and side. Side angle side, similarly, the similarity statement for that, and it's, as you can read here, defined as such. The measures of two side lengths of one triangle are proportional to the measures of two corresponding side lengths of another triangle, and the included angles are congruent. So let's take a look. Example 1. Determine whether the triangles are similar. So as you can see, all you are given on triangle ABC and then on triangle DEF are side lengths. So on ABC you've got 10, 8, and 6. And on DEF you've got 15, 12, and 9. So this can't possibly be angle-angle nor side-angle-side similarity. It can only be side-side-side. But let's make sure as we go through this, of course, that the sides are in proportion. So in terms of the values or the lengths, pardon, of the sides, we've got AC as 6. We've got DF as 9. 6 is to 9, or 2 is to 3 is that particular quote-unquote, we can say, scale factor. If, in fact, however, all of them are the same. And we would be then able to say that, of course, the triangles are similar, and that is, of course, your scale factor officially. Let's continue, though, because we have to make sure all of the sides have the same scale factor, all the corresponding sides, that is. So BC, of course, is 8. We see there EF is 12, and of course 8/12 is also 2/3. Fantastic. We've got two fractions that appear to be what the scale factor will likely end up being. Let's make sure that the third corresponding side ratio is in fact the same. Is AB what, 10? As you notice here, DE 15 as it is to 2 to 3. In other words, is 10 to 15 equal to 2 to 3? It is, of course, and because obviously that's the same ratio on every single comparison of corresponding sides, we know that these are similar. And yes, the statement would be side, side, side similarity. There's another version of this that you guys can note. You can also write that notation, side, side, side similarity. And it is true fully that the two triangles are similar as such. Triangle ABC is similar to triangle DEF, and it's in that exact order too. All right, example 2. Determine whether, again, the triangles are similar. We've got a side, an included angle, and a side on one triangle, a side, an included angle, and another, and then again a side on that triangle as well. So we're going to shoot for side, angle, side. Let's see if this is what we're hopefully going to match up to with regards to the definition, or if in fact it meets the definition requirements. So we'll say 3 is to 4, MN is to QR, as they describe here, as hopefully NP is to RS, or 6 is to 8. And it is hopefully true, right, that 3/4 equals 6/8, and it is, of course, the case. So we know that this proportion is a true proportion. MN is to QR as NP is to RS. All right, but that's not enough. We just have side and side to compare with. We can, though, or should still, though, look at the angles that are included, and as you can tell, because they're both 70 degrees, angle N is equal to angle R. So therefore, of course, we note that they're also congruent. And angle N being congruent to angle R, paired with the size in proportion, we can then go to triangle NMP, similar to triangle RQS by side angle side similarity. And another way that we can write this, just like we did example 1, as I'll go ahead and do that, side angle side similarity can be written also like that. And again, those two triangles are similar and in that particular order. Make sure we we do that. Moving on. Determine whether the triangles are similar. If so, write a similarity statement and explain your reasoning. So for problem number 1, we've got two angles. Angle A congruent to angle D, and we've got angle B congruent to angle E. We don't have anything else in the picture. However, that is enough to essentially say that yes, these are similar. Triangle ABC is similar to triangle DEF by angle similarity. Okay. Notice that angle A and D are congruent, so they come first in the statement. B and E come second. And then lastly, C and F are the third variables. But again, all we knew to start with were those two corresponding angles and the pair that you can see being congruent. Let's take a look at number 2. Number 2, we've got what appears to be a side, an angle, and a side on one triangle, and then again side, angle, side on another. So our guess is, or should be, that these are similar by side, angle, side. But let's see if that's the case. If we were to maybe take our proportionality statement to the point where we can see that the larger of the two sides on the left triangle, 36, is to the larger of the, again, two sides on the right triangle, 24. Is it true that 36 is to 24 as 20 is to 18? Well, if you double check 36 over 24, that ends up being something that you can reduce, of course, dividing both by 6, such that you get, 12, you can divide by 6 as well, but if you divide by 12, you get 3/2. The second fraction, however, if you divide 20 by 18, is not 3/2. It is reducible. It ends up being 10/9. So because these two fractions are not the same, we cannot say that they are in fact similar. Again, I cannot say by side, angle, side that these are similar. Let's move on. As we can see, number 3 in particular, you've got a triangle within a triangle. Anytime this is the case, but also when you see in this particular instance two parts of which are parallel to each other, there is some added pieces we need to go ahead and put in here. We need to note that thanks to corresponding angles, if the lines are parallel, which they are, then corresponding angles are congruent. We can also say that angle T is congruent to itself. So that hopefully should give us some perspective on the possibility, the strong possibility actually, that angle similarity is what we can see. And I actually would argue that that's the case. So yes, and notice how I write my triangles. I'm going to say triangle TSL is in fact similar to triangle TRU. Again, TSL, TRU, and the reason they're similar again is by angle similarity. An angle that I didn't highlight that I still could maybe is that these two angles are also congruent by virtue of corresponding angles being congruent. If the lines are parallel, corresponding angles are congruent. So I could have used those two angles instead. It's still angle similarity, and yes, you got to make sure too that the statement is in this particular case in the right order, where T is first because it's congruent to itself. As a reminder, we can say this because angle T, being shared by both triangles, we can argue as congruent to itself by the reflexive property. If you guys recall, we can use that that property in context. And then again, noting that in the statement, and then S is congruent technically to R, although you got to be careful. This angle is technically TSL, and this angle is TRU. So they're not individually something you can write as single letter angles. And then lastly, L and U. In that order, angle TLS is congruent to TUR. Okay, so let's take a look. I think number 6 is a good finishing problem here for us. So we can see here that all we are given are side lengths of the two triangles in question. So my guess is that this will be side similarity, but let's see what we have. So let's do the analysis of picking maybe the smallest sides first. So 24 is to 15, comparing left to right triangle, as 32 is to 20. I'll put a question mark here because we don't know if it's true yet that they're all equal. Again, 24 is to 15, as 32 is to 20, as 40 is to 25. All right, the question again begs is, are all three ratios equal to one another? In other words, 24/15, which is reduced to 8/5. Is 32/20 also 8/5? It is. And is 40/25 also 8/5? If you do the analysis in your calculator, yes, you'll find that all three are in fact the same number. So this checks and that checks. Of course, then the scale factor we would argue is such. The answer, of course, is yes. And let's be, again, mindful of order. Order does matter, so I'll say triangle IGH is similar to triangle SQR. And the reason, again, whether it's obvious or not, side similarity. Okay, so side angle side, and angle similarity. Please practice certainly numbers 4 and 5 on your own. I'd like you to do those on your own. It does turn out where, and you'll find this to be the case, that they are both side angle side similarity statements that you can prove. But please try those on your own. On the next page, we're going to go ahead and continue with the example 1 and 2. Let's read though. It says similar triangles can be used to find measurements. So in example 1, it says triangle ABC is similar to DEF. And because that's the case, we can make the following statements. AC is to DF as BC is to EF. And they wrote that for you. So 18√3 is to X as 18 is to 9. Okay, we can cross multiply here, and therefore 18x equals 9 times the quantity 18√3. We can then, as you can see, divide by 18. I'll show that, so that these are going to nicely cancel. You're then left with x simply as 9√3. So on the smaller triangle, 9√3 is the dimension that is corresponding, of course, to 18√3. Okay. Similarly, if we're going to go ahead and find side y on the larger triangle, though, AB is to DE as BC is to EF. So if we set up our proportion, which should be true, of course, again, because they told us that they were similar, y is to 18 as 18 is to 9. Cross multiply, 9y equals 324, divide by 9, I'll show that step, and therefore y is equal to 36. Again, the larger triangle has that third side dimension. Example 2, a person 6 feet tall casts a 1.5 foot shadow, long shadow, at the same time that a flagpole casts a 7 foot long shadow. How tall is the flagpole? Now we are going to make the case here. We see a right angle here, so side angle side. We don't know this side, but side angle side, denoting that we do have similarity. But also from there we can write 6 is to x as 1.5 is to 7. If you wanted to double check and do 1.5 over 7 just to kind of get a fraction out of that, that ends up being 3/14. Now we are going to be solving for x to essentially prove that they are similar triangles, but by virtue of solving for x, and you can of course cross multiply, you get x to be 28 feet. If that's the case, you can double check, but 6/28 is in fact the exact same fraction. So they